Okay, so today we are going to be talking about loops, specifically the for loop. So, first we'll go over the syntax of a for loop. So I'm going to delete this right here, and you type in the word for. I don't really know why it's called a for loop. It's like you do it for as many times, I guess. I don't know. But type in for, and then the first part of it is called the initialization. So usually you use an integer, but you can use a double too. You'll say int I equals 0. Now this, you could name this integer whatever you wanted it to be. It doesn't really matter, but I is usually kind of seen as the generic generic term for it. And then you have to put a semicolon in there, but this is not the end of the line. So it's it's a little bit weird, but it's like, I don't know. It's like we're going to basically be doing 3 lines within just the parentheses of here. So first we have to initialize it, which is a complete statement, so we put a line at the end. Then we do something called the test. And so in like math and at schools, there's like less than, greater than, equal to, and greater than or equal to. And so those are the things we can use. This would be equal to, but we never ever use that in a like a loop, because then it would only run one time. So, but that is how you do it with 2 equal signs, which we'll talk more about later. And then that would be less, greater, less than, greater than. Is it less than? Yeah, less than. And then greater than. And then to show less than or equal to or greater than and equal to, you do the sign and then an equals. Or the other sign and then an equals. So we will do... we'll do smaller than. For now, we'll do smaller than, let's say, 5. Then we end that with another semicolon. And then the third part is called the update. Now, most of the time when you're doing an update, it's going to be I++, or maybe I-. And I think it's optional to have the semicolon at the end of that line, so I usually don't do that. And then we think this is kind of... Then you have the opening and closing braces to indicate that all the code inside of here is part of the for loop. So now what a for loop does is, first of all, it runs... Well, actually, let's put a little bit of code inside of it first, like system.out.println hello. So if we run this, we compile, take a second, and then run, it's going to say hello 5 times. So what the for loop does is, first of all, it says, okay, let's create this variable called I, and we'll set it equal to 0. Then the next thing it does is it goes to the test, which is that middle section, and it says, is I smaller than 5? Although if we had a different thing right there, is I greater than 5? Is I greater than or equal to? Whatever it is. But you do, is I smaller than 5? 0? Yes, it is. So then it's kind of confusing, because it doesn't go to this part next. It actually runs this code, whatever that code is, and that code can be as long as you want it to be, as short as you want it to be, whatever it is, it'll run that. Then it comes back up to here, runs the update, which alters that variable, because otherwise you just have an infinite loop. So it's going to update that. Then it goes back to the beginning. It doesn't initialize the variable again, but it goes back to the test. It tests, is I still smaller than 5? If it is, it runs the code, updates, and it keeps on going like that until eventually the test is false, and then it skips and starts from the end right there. So there's 2 kind of main ways to go about writing a typical for loop. So the way that most people start off with is they go int I equals 1, because that makes a little bit more intuitive sense, because we usually start counting with 1. And then you would say I is smaller than or equal to 5. Because that makes sense. You start it counting at 1, and then you end up with 5 things. Now, that's generally seen as more intuitive, and for the purposes we're going to be using this, it's probably fine, but it's actually better to use int I equals 0 like I had before, 0, and just have this be less than 5. When it's just less than 5 and it starts at 0, it's still going to be 5, so that kind of makes intuitive sense. You wouldn't use int I equals 0 and I is smaller than or equal to 5. That wouldn't make any sense. That would, or then it would have to be 6 or whatever. But the reason we do this is because computers actually start counting at 0. So this will be helpful later on when we're working with things called arrays, because a common use of for loops is to kind of iterate through the parts of an array. Because an array is like a big box that has a bunch of little boxes inside of it, and so you can use a for loop to go through each one of those little boxes. So that would be more useful later. It's also good practice to just start using 0 and getting used to that. And then also for something we're going to be doing a little bit later, this makes actually the math a little bit easier too. So we've got that, and as I said before, that's going to print out hello 5 times. Now, a for loop has no kind of special rules about what code can be inside of it. I mean, besides the obvious stuff, you can't have a function inside of it, you can't have a class. But one of the interesting things you can do is you can have another for loop. Now, before we actually finish this loop, I want to talk about something called scope. Now, scope, when we talk about scope in computer science, what we mean is where variables exist, right? If I try to go out here, and I try and say system.out.println I, right, it's going to say I don't know what I is. And I mean, I guess that would make sense, because I isn't declared till down here. But even if we put this, here, let's get rid of this for loop for now, just so we don't get an error. Even if I were to put it down here, I compile, it's going to say, it doesn't know what variable I is. And that's because the I variable, if we put it in here, and my tab is a little bit off, but if we run that, it's going to count 1, 2, 3, 4, or 0, 1, 2, 3, 4. So it works fine inside of the for loop, but not outside of the for loop. And that's what we're getting at with scope. So the int I only exists within that for loop. It doesn't exist outside of that for loop. Likewise, if you have a variable even in one function, you can't access it in another function. So kind of think about, if you declare something inside of curly braces, it exists within those curly braces, but not outside of those curly braces. So now, if we wanted to make a second for loop, right, and I told you guys that I was the convention for it, it's not bad to have a more descriptive name, but if you're just iterating through things, it doesn't really matter. You can just do for, and we can do int I equals 0, I is smaller than 4, I plus plus, and then system.out.println, do a little asterisk maybe. Put that in a string. And if we try and compile and run this, it is going to again throw an error because int I is already defined in that scope, because even though this is a for loop, the I is still within these brackets that the I was declared previously, and you can't initialize two variables of the same name. So what we do is we call it J. For nesting for loops, the convention is I, J, and then K. Theoretically, if you were to do like 4 nested loops, you'd do like an L, I guess, but we're never, like, that's probably never going to use, even at most advanced things. At most, you'd be using 3. Now, an interesting application of this, right, is we can use this to kind of automate some interesting shapes. Because if we have like a square of asterisks, right, like it is, you could call each line, and you could even have each row. Like, what we could do is have only one for loop and then just have it print out each row. Right? And just have, like, okay, print that row 5 times, and then you'd have a square. But, again, that's also kind of redundant because you're just printing the same character over and over again. So what you can do is you can use a for loop like this, right? And so it's going to say, okay, for int I equals 0, that's true. It goes into here, right? Then it's going to print out this asterisk 4 times. Once it's done that, it's going to leave that. It's going to hit enter, essentially, with the system.out.println that's blank. It's going to go back up here. It's going to say, yep, I is 1 now, not 0, but it's still lower than 5, so it's going to print out another 4, hit enter, and it'll keep on doing that until you have 5 rows of 4 asterisks. So if we compile this, and we run, sorry. So the one mistake I made here is that shouldn't have been print line. That should have been print, because we want them to be printed on the same row, not each one on a different row. That's why it made like this kind of, I guess it didn't save the output, but it made that kind of that, it was like, yeah, it was 4 asterisks where they were like vertical. So if we change that to print, now it should work. And yeah, it's not necessarily a square, but it is a shape, and we can change this to be 6 and this to be, 4, and it'll still work. And that's kind of, it's a little bit more convenient too, because you don't have to like count how many of the asterisks you're typing in. It's a lot simpler. You can change everything really easy. So that's a nested for loop. But that is a fairly basic one. In a little bit, we're going to talk about kind of some more interesting applications of it. So now we're going to talk about something I kind of touched on yesterday, I think, and it's called infinite loops, right? And that would be if I have a variable out here, or actually, let's say right here, right? I'm like typing, and I'm adding my stuff, int j equals 0, and if I were to accidentally say I plus plus, right? That's a very common mistake, right? Like, imagine when I first made that mistake, and I had int I equals 0 in the outer one and in the middle one, right? What if I'd forgotten to change that I plus plus? That would have got me stuck in an infinite loop, because j would have never changed. It would always be smaller than 6. So again, that'll be a runtime error. I don't want to try that out just because I wouldn't want it to like crash the recording. But it shouldn't do anything bad to your computer, but just something to be on the lookout for. Yes, Kemper?
Mine printed what I typed in like 20.
Yeah, because you forgot to do a system.out.println. Because you need to hit enter, essentially. Here, I'll explain. Here, type in system.out.println just to blank. So what Kemper did, what his mistake was, is he didn't have this right here. So it basically, all the outer for loop did was multiply the inner for loop by 4. So what you need to do is, if you want it to create this kind of this square, two-dimensional shape, you need to do system.out.println a blank one just to kind of hit enter so that you can create each row, not just one long row. Now, we're going to go away from loops for just a second to talk about something that's really helpful, and it's called pseudocode. So pseudocode is kind of, it's not really a real thing. It's not like a language like Java. It's where basically you write out your kind of logic in English, kind of, and then you end up kind of translating that into code. Because you can talk to a friend and explain how your program is going to work. A step beyond that, you can kind of almost be like, okay, for, 5 times write a star, and you can kind of write stuff out like that, and then that kind of creates an easier like middle step, because then you can kind of get all your your logic out onto the screen without having to get caught up so much in the syntax before you do that. Because otherwise you might be like, okay, how do I do a for loop again? You have to go back and check the book maybe, and then by the time you've done that, you forget what you were going to do next. So that's kind of a helpful tool. You usually don't have to turn in pseudocode for any sort of programming project, but it does make that easier, and it's something that you should know what it is. Now we are going to go back to for loops for a little kind of exercise thing. So we have a shape, let's say that many, whoops.
You could just one line star thing.
So, am I making this right? I don't know, but essentially what I'm trying to do is I'm trying to make a kind of inverted triangle, like a kind of V with a line on the top type thing. Now, what we've been doing so far is we've only known how to print out squares, right? But you can see how kind of the same logic would apply here. It is kind of redundant, because right now you'd have to write like technically each line that you wrote in the system.out.println would be different because it would be a different number. But it's still redundant. Like that's kind of the thing with redundancies. It kind of evolves as you learn more and more. Originally, it was just like two lines that are the same in two different places, but now it's kind of you kind of get a feeling for redundancy and how that could obviously be a lot simpler. Now, how we would do that is by utilizing this variable, because that variable you can use it for the test, but you can also use it inside of the for loop to do operations. And I think I did that right here, where I was like system.out.println, whoops, that was an L, J, right? Because then that, when we compile and we run it, oh, whoops, that was supposed to be a println, supposed to be a print, compile, run, it's going to print out 0, 1, 2, 3, 4, 5. So it's not just, even though we're having it only print out one thing, J is changing each time the loop goes through. So we're able to kind of create this, these like identical rows that are composed of different things. Now, how we can apply that to here is by, we can do something like this. So let's say we're just going to make this out of asterisks. Whoops, sorry. Need to put that inside of a string. Now, instead of having j always equal or always smaller than 6, right, which is like that, then you're always going to run that loop 6 times. What we can actually do is have it smaller than or equal to something that is changing, because then we want the rows to decrease each time. Now, to do this, what we're going to do is kind of like some like algebra almost. So, but what we do instead in programming usually, you could do this and think of it as like solving for the slope and stuff. But generally what we do is we create like a table. So let's say like line number, and then over here we'll do something like number of stars. And this is just in commented code. And you could write this on paper too, which is probably what I'd do. But, so for line number 0, which will be the first line, because I starts at 0. And in fact, let's even rename this to line, so it makes a little bit more sense. Oops. So line number, when line is 0, we want number of stars to be equal to, what do we want it to be equal to again? I guess it doesn't really matter, but let's say 10. And then for line 1, we want it to be equal to 8, and have it decrease by 2 each time. So then, like, 2, and we want that to be equal to 6. So then we can see the change each time. It's going down by 2. And then we can also see the y-intercept pretty clearly, which is 10, right? So right down here we had our j. We're going to say j is smaller than 10 minus line times 2. I would recommend putting in some parentheses around these things, even though you don't really need to. But in case you were to do any funky math, when you're writing out longer expressions like that, make sure to kind of that you know what's happening. So that's why I'd add the parentheses right there. And so this is going to be essentially the equation for a line. We found the slope, and we found the y-intercept. The reason I think it's actually useful to start with line equals 0 is because then it's super easy to figure out what the y-intercept is. You just have to look at it. Instead of, if we started with 1, then we'd have to calculate the line-intercept. The y-intercept. Like if this was 1 and then 2 and then 3, the y-intercept would be 12, and we have to go backwards and calculate that. So now that we have this, let's have this print out 5 lines. Now I don't already have this shape kind of in my mind, so I'm not actually sure how many lines it's going to be. Okay, so it looks like, yeah, that looks about right. So as you can see, we've kind of got this triangle here, but clearly we are missing something, because it is a triangle, kind of ish, but it's a right triangle, and what we really wanted was a a centered isosceles triangle. So what we can do is we're going to throw in another for loop, and what are we going to name this variable? Let's say we could do j again, even, because we're not going to nest it with the other one. So maybe we'll do that. So int j equals 0, colon, we'll do j is smaller than, we'll leave that for now, and then we'll say j++. And then make our curly braces. And so what we're going to want to do is, to get this to be centered, we need to add spaces in. Right? So we'll do like a system.out.print, and then just add a space in between 2 quotation marks. So, to figure out how many spaces we're going to need, again, we can go back to this table. So at line 0, we need 0 spaces, right? Because it's at the edge, and that's fine. I mean, we could, if we wanted it to be offset more, the whole triangle, we could add some, but we should be fine for that. For the next line, we would need 1 space. Yeah, 1 space, and then down here it would be 2 space. So the y-intercept, 0, and it's increasing by 1 each time. So what we can say is just j is smaller than line. Technically it would be line times 1, because that's the slope, but simplify that to line. And then ostensibly this should run, yeah, and it does. So it creates this little kind of triangle guy right here. And so yeah, that is a large aspect of kind of working with for loops. It's going to be creating these structures that initially aren't obvious how to make them not redundant, but then you have to use a nested for loop. So this will be like in my class, we did a whole bunch of work with these. Like if we actually look, let me see if they have this. Into my password. We actually did a version of the Space Needle. Yeah, with, let's see if they have it. Is it gonna load? Oh yeah, there it is. So that is what we had to do. And again, making sure to manage redundancy, right? So if we like zoom in here, right, you can see that this number of colons gets smaller each or larger each time. For this line, that was just one for loop that just had it go out for a certain amount. And then down here, we had to make these characters. And yeah, it was fairly complex. Oh, there's Mason. Hey, man. So I'm gonna pause. Okay, so you can kind of see where you would use a for loop in here, right? Like instead of writing out this entire row right here of these little quotation marks, right? Set up a for loop to write it out X many of times, however many times you want it to be. Right here, this is a similar thing to the triangle that we were doing, right? Except instead of printing out just a slash, we actually print out a slash, a triangle, 2 slashes, like that. And then we say how many times we want that, how many times is it decreasing each time. And then we, at the beginning and ending of the thing, we add in these like extra little characters at the end. So we kind of did that. And, you know, it ends up just being a bunch of basically the same thing. And you can actually, you use functions because this right here is the same as this right here. So you can use that again. The other thing that we did with that is we made it scalable. We made it so that you could increase this by a size of 2, decrease it by a size of 2, all by changing one thing. And that's what we're going to talk about next. We're going to talk about something called a class constant. So, a class constant is called a class constant because it's declared in the class. Remember how I talked about earlier how variables they exist within the curly braces in which they're defined, right? If I had a public static void main method and I declare a variable right here, it only exists in main. Even if I call a method within main, that variable stays within main. And there's a way to get around that we'll learn about later, where you can actually like give that variable to the function that you're calling. But if you want something to be available to all of the functions in your program, what you have to do is you have to declare it up here. Kemper, do you have a question?
Yeah. Ours isn't working.
Alright, let me pause the recording and help with that. Okay, recording's back on. So, how you write a class constant is you do public static final, and then you say what the type is. This could be a string, this could be a double. We're going to have it be an int. And then you have to name it. And how we name a class constant is we do all caps and separating the words with an underscore. So we could do something like size change, right? And then we could say equals 1. So now we can access this variable anywhere within this program. Now, the thing about the final keyword is when you say final, that means this value cannot change, right? And you might think, well, why would you have it not change, right? Like, you may as well have it be able to change. But the reason we want to do this is a lot of times in programming, you know, it would be easy. We could define every single variable that we ever use up here, right? Well, yeah, that would work, right? And then you don't have to worry about, oh, it's not in this method, but it is in this method. But the reason you don't want to do that is you want to keep data protected, right? You don't want to accidentally access some variable that you didn't want to be able to access. Like, does that make sense? Like, if I were like, okay, I'm going to set int I equal to 0 up here. And then I were to later on, and so I use it where I wanted to use it, but then later on I forget and I use it again, right? Like, that could have a downward, a bad effect. The other thing is, you know, like, it can get even when you're creating larger applications, it could be like, that could be someone's, like, personal information, right? Like, their password or something, and you're like, and you accidentally alter it somewhere else, and then they can't log in, right? Like, that's where you want to keep things kind of protected. And so, by saying public static final int, that keeps it from changing, makes it so you don't have to worry about that. If you remove the final, you can change it. And we won't be changing this at all, but generally it's seen as good style to only, with some exceptions, but only ever declare a class constant. Don't declare a class variable. So make sure you have that final there. Otherwise, that's kind of seen as lazy and dangerous programming. So we have our public constant up there. Now, why would you use a constant? Right? Well, first, I'll explain why we're going to use this constant. We are going to make it so that our little triangle can actually scale. Right? If I say size change equals 2, right? Then our triangle will get twice as big in every direction. Now, why not just, add that number in? Why not just say, okay, times 2, somewhere in it? And the reason why you don't want to do that is generally you don't want random numbers floating around in your program, right? You want someone to know exactly why you're doing something, right? You don't want someone to just be like, okay, what is this random times 2 here for, right? A class constant allows you to kind of define it a little bit, because then they see, oh, size change. That makes more sense. And even if it's especially unclear what it is, you could even add a comment up here and explain what size change is. So they go, what's size change? They go check, and it has a comment that tells you what it is. So one of the reasons that's for organization. The second reason is because then, I'm going to have this size change in multiple spots. If I just did times 2, right, I'd have to go and find every spot where I put times 2 and change that to times 1 if I wanted it to be times 1 now. Whereas with this, I can just change it in one place and it updates everywhere. So, we're going to start off with size change equaling 1. Let me just check something. Okay. So, just with it equal to 1 right now. Now, line, we want it to be smaller than 5 times size change. Because we want it to scale with size change. If we want it to be 2 times as long, we want it to be 2 times as many rows is what we're going to need. The next thing we want to do is we go down here, right, and this is where we would, let me see, we want it to be size change right here, right, because we want it to start twice as large or 1 time as large, and then also we want it to, I'm trying to think actually, do we want it to decrease twice as fast too? Let's just say, yeah, and we'll see how it is. If this, I'm not an expert on how scaling shapes works, but we'll try this out. We'll see what happens. So if we compile this and we hit run, we should get the exact same thing, because our size change is just 1, which is good. That's what we wanted. Now, go up here, change it to 2, compile, and run. And let's see, what did we get? Wait. Okay, so the one thing we forgot is we forgot to add. Wait a second. Oh, I see, yeah, right here. We forgot to change that for the spaces as well. So then the size change. Now let's try this. And it's a good thing to compile after you fix every error, right? I think we might still have some more mistakes to figure out. But, hey, so we compiled it, right? And it's starting out longer. So this, the spaces are off even. Okay, so I don't think we need that size change right there. No, I guess we did. Okay, well, so now it's, okay, actually no, we did need to remove that size change. So we did that. And now it's it's looking a bit better. It's still not perfect, centered in the middle.
Ours is doing 4.
What?
Ours is doing something wrong. We did something wrong.
Okay, I'm going to pause the recording. Okay, so it is working on everyone else's computer, but for some reason not on mine. It's a little bit off. I wouldn't worry too much about this as long as you have the general idea, because again, this will be a project that you will do, and it'll make more sense then. This was kind of me trying to just randomly kind of come up with something. When I was working on the project for my class, they actually gave us it at size 12 and at size 4 and at size 8, and then you could kind of see, okay, oh, this is this long in these and this long in those, and kind of figure out, again, using that table thing that I showed you, what the values was supposed to be to change that. So I guess this will just take a little bit more fiddling around. It looks like I have the exact same code as everyone else, but for some reason my triangle is off. So yeah, Kemper.
Can we do a picture now, like the Space Needle, but less complicated? Like the Eiffel Tower.
We're gonna move on from this because that would be something you do more as like a project. Yeah, like the Space Needle thing that took like
2 hours.
I mean, it took me like 2 hours because I kind of already knew the thing, but it's usually takes like 4 to 5 hours for a project like that, is what they were saying it was. So the next thing we want to talk about is okay, so I'm going to get rid of this size change thing because obviously that's not working on my computer for whatever reason. So we're going to stick.
Should we keep our size changes? Or
What? Sorry.
should you also delete them?
You can if you want. It's We'll change that to 10. So I want to do something. We're going to talk about how to use different variables in methods. And actually, let's get rid of this triangle thing, because that's overly complicated for what we're going to be doing. All we really need to think about is just is fairly simple. So we have this, our public static void main, right? And so in public static void main, we are like int number or num of jelly beans equals 5, right? Now, and maybe int num of gummies equals 6, and int num of beans equals 2. So maybe this is our like, let's say we're running a shop, okay, and we sell jelly beans, gummies, and beans, and we want to be able to kind of display on the board how much we have in stock of each of these things. Now in a real program, right, these numbers would be changing, there'd be user input. We don't know how to do that yet, so we're just going to keep this as 5, 6, and 2. Those are our let's even think of that as our prices, right? Jelly beans cost $5, gummies cost $6, and beans cost $2. Okay, and we could type out like, oh, display this, display this. Let's have a function to display our menu. Okay, so we're going to move outside of public static void main, and we're going to do public static void display, or whoops, this first thing should be lowercase display menu, and we'll do that, okay? So now we have this function, right? And let's say system.out. println, we'll say, and this is an example of string concatenation that I talked about before. We'll say number, whoops, that's supposed to be a quotation mark, number of jelly beans, oh my gosh, whoops.
Wait, isn't there still a quotation?
Yeah, put a quotation mark right there,
Oh.
because this is, we're writing out text, because this is what we want to display next to that number. No, number of jelly beans equals, and then we'll do a space.
You did 2 dot things.
What?
Not equals.
Yes, because it's a string.
Oh.
It's not, we're not typing out math, this is just what we wanted to display. And then we'll say plus num of jelly beans. And then we'll hit the colon right there. Now, I'll copy this, I'll paste this, which you should kind of be cringing at, right? Because this is obviously very kind of redundant. We'll change this though. It's not technically redundant, but we'll say gummies, and we'll say beans, and then we'll change this to num of gummies and num of beans. So now if we try and run this, right?
What, display the numbers?
Well, first of all, the first thing I forgot to do actually is we need to call display menu, right? Otherwise it's not going to run that code ever. The other thing it's going to say is cannot find symbol, right? It says symbol variable num of jelly beans, so it can't find that. Now why it can't find that is again because we're talking about with scope, right? These variables only exist within the main method. They don't exist within display menu. So one way we could solve that is we could take them outside and turn them into class constants, right? I mean, I guess that would kind of make sense for this purpose because prices don't usually change, right? But there's another way to do that. And the way we can do that is something called parameters, okay? So how we declare parameters is we go first to the function we want to take the parameters into, right? And I'm going to say int num of jelly beans, right? And then I'll do a comma. I'm going to say int num of gummies, comma, int num of beans. So now I have that there, right? And now, if I comment this out for a second, because we haven't fixed that, we can compile. Oh, I mistyped this gummies right here. But if I fix that and we compile, it's going to work. Now, what we've basically done is, remember how this thing up here says string args, right? The main method. This is the same kind of type of idea, right? What we're saying is we want, when we call this function, we want to be given 3 numbers. We want to be given the number of jelly beans, the number of gummies, and the number of beans. So what we would do, right, is we can pass numbers in. If we pass in 5, 5, 5, and we hit compile and run, it's going to say number of jelly beans, $5, $5, $5. If we change this to 6, which one is going to be $6?
Jelly bean.
Yep. Because it follows the order, right? When I put the 6 first, it's going to say, okay, assign that to number of jelly beans, and assign that, the next one, to number of gummies. So then when we run that, it'll be $6. Now, furthermore, what we can do is we can even pass in num of jelly beans, comma, num of gummies, comma, num of beans. And I guess this should really be like cost of beans, and because we're thinking about prices now, and cost of gummies, cost.
You forgot the jelly bean cost.
Yeah.
Costco.
Okay, so we've kind of changed that up a bit. Oh, and then we're also going to need to change these. Cost. Now if we compile and we run, we're going to get exactly what we wanted to. Number of jelly beans. Okay, it still says number of jelly beans is $5. Whatever, that's fine. I'm done changing those things. But it's displaying what we wanted to display, right? It's displaying the 5, the 6, and the 2. Right? And that's great. Now, let's say we want to add tax to our gummies, right? So we could do that with some simple math that we learned how to do, right? Kemper, do you have a question?
Why does it still show number of gummies?
Number of gummies. That's because I forgot to change it right here. Sure, we can change that. Cost. Now let's say we want to show the full price, right? And we have a 10% sales tax here. So what we could do over here is we go int, or sorry, not int. Oh, whoops. Control Z. We just take our cost of jelly beans, and we're going to say plus equals, because we're going to add onto that the cost of jelly beans times 0.1. Now the first issue here is that we've been working in ints so far, and clearly we need to be working in doubles because we can't do decimals. So, and I mean, honestly, that makes more sense for money anyways. So let's change these to double really quick.
So it can show decimals?
Yeah.
Round them?
Yeah, and it won't round, because otherwise, yeah.
Is it needed for tax, right?
Yeah, and in fact, this thing wouldn't even run right here, because it would be trying to store a double inside of an int, and that doesn't work. So we have cost of jelly beans plus equals cost of jelly beans times 0.1. So that's going to excuse me. That's going to basically add the sales tax on. And if we and we could do that for the rest of them too, right? But for the sake of time, I won't. So we have the cost of jelly beans, compile, run, and it says $5.5. Right? That's what we wanted it to do. Now, what if I go up here and I say system.out.println cost of jelly beans? What is that going to display? That's a question.
It's on another line.
No. What is it going to display?
Oh.
Is it going to display 5.5?
No, it's going to display 5.
Yeah.
Because it's not the tax. It's just the cost of jelly beans.
No, but think of it. So you're right. It is going to display 5. Now the reason it does that is because down here, right, we are changing this variable. We're saying cost of jelly beans is no longer 5. It is 5.5, right? Mm-hmm. And that's why it displays right here. But here's the thing. Even though it has the same exact variable name, cost of jelly beans inside of display menu and cost of jelly beans outside of display menu in the main function are not the same variable. They have the exact same name, but due to scope, right, they both exist, but they are both different. So when you pass in a variable using a parameter like this, it is not saying, okay, like, give a reference to that variable. Like, when we change cost of jelly beans inside of menu, we are changing a copy of cost of jelly beans, right? When we say, okay, put in cost of jelly beans up here, we're saying what value is in cost of jelly beans. Whatever that is, give it to this random variable. That could be named whatever. We could just name this jelly beans. And if we changed this to jelly beans and this to jelly beans.
You put F jelly bean.
Okay. And this to jelly beans. Oops. And we need the plus sign right there. And we compile that, and we run that. That's going to work just fine. Because again, it doesn't care what it's called, it just takes whatever value that is, and it puts it in there. Another thing we could do with this, we can even put in an expression. We could say, cost of jelly beans times 2. And if we compile and we run, it's going to give us $11. Right? Whatever value is there is what it's going to use. Does that make sense to everyone?
Wait.
Yeah.
When you change the jelly bean name for the X to the last one.
For down here?
Yeah, for the system print line with the green and the number and everything. Well, actually, well, all the
Over
times
here?
you changed the jelly bean from cost to just jelly bean, what did it do?
So that's, again, it didn't do anything. Because jelly beans does not have to match this name up here.
Oh, because it's outside?
Yeah, jelly beans is a new variable that I'm declaring.
Inside the scope?
And it just gets whatever value is put in up here.
Is it inside the scope?
So jelly beans exists within this function. Cost of jelly beans exists within this function. But the value of cost of jelly beans gets put into the display menu. Not the variable itself, but the value. Okay, so.
Wait, so then how can you double it outside of it?
Because I can double it right here, because again, it doesn't care what cost of jelly beans is. It says, okay, what's cost of jelly beans? Cost of jelly beans is 5. So put 5 in there. Now what do? 5 times 2, 10. So then it gives that value.
But then how's it 11? If it's a different variable that's being...
Because you're adding the 0.1, the sales tax. That's what you forgot.
But it's jelly beans, so it's a
Yes,
different
temper.
variable?
See, if I remove the sales tax, and I do that, it's going to be $10.
Alright.
It was just because we were adding 0.1 to it. But if we remove that, yeah, it's going to be cost of jelly beans times 2 is what it displays. So,
Otherwise, it's cost of jelly beans plus, like, the times 0.1.
Before it was, because it was adding the sales tax. So, now, we've talked about how to pass things in. Right? And, I mean, maybe we got a bit theoretical. I'm not really sure why you'd put cost of jelly beans times 2 right there. But that was just to kind of show you guys how it works. Let's remove the times 2. And, you know what? The other thing we could even do is, I won't really mess with that, but we could even turn probably this into a function. But no, because that wouldn't be useful. Never mind. But yeah, so we've done this. Maybe in the future we could turn that even more, but for now we'll leave it like that. So that's pretty good. Here's another thing we could do. This is called overloading. And it sounds like really cool, like overload, yeah. But basically what it is it's, you can actually you can have two functions that have the exact same name as long as they have a different number of parameters. Okay? So let's say this one has no parameters, right? Because, you know, sometimes we have jelly beans. Sometimes, let's say sometimes we don't know what the cost of jelly beans is, right? Well, we don't want it to just like go, failure, you didn't give me any numbers. Because if we tried and called this and didn't give it any numbers, it would fail. It would throw an error. Right, so let's say, you know, if we don't have any numbers for our costs, just do system.out.println menu not available. Right? So it's the same exact name. Right? They're both called display menu. But if we run it right now, we get exactly what we had before. I'm going to delete this system.out.println too. We get exactly what we had before. But if we remove all those variables from passing in, because let's say we didn't pass in those variables, we don't know what they are. Now when we run it, it's going to realize, oh, okay, I'm not supposed to run that display menu. I'm supposed to run the display menu that says menu not available. So that's what overloading is. And that's something like let's say we wanted to draw like a box, right? You could pass in, like, I want the box to be this long and this tall, right? But what if I just wanted to display a default box, right? I could say just draw a box and it would know that I just wanted the default box. Does that make sense? So this can kind of...
actually draw a box?
What?
Did it actually, like, draw a box?
No, not right here. So this can be useful, like, this is how like a lot of things can work sometimes. Like when you pass in system.out.println, right? When you pass it in an integer, right? it's expecting a string. So when you pass it an integer, it would usually go like, well, that's not what I wanted. I can't use that. That doesn't work, right? And it would throw an error. But what they've done is there's actually a system.out.println that takes a string. There's also one that takes an integer, and there's also one that takes a double, right? And the integer one, it says, oh, okay, I'm passing you an integer. It says, okay, run this system.out.println, and then that one, its first step is it converts that int into a string. Does that make sense? So you can kind of accept multiple different types of input, but still have everything run the same. Does that make sense? No? Because, like, if we wanted to write our own version of system.out.println, right? And let's say we wanted to write all the behind-the-scenes code, yada yada. We did that, right? And we say, okay, system.out.println, it's going to accept a string, and we will call the string string. Right? Now, we could run that, and that would work fine if we pass in strings, but as soon as we pass in an integer, it's going to say, hey, I wanted a string, not an integer, I can't run, and it's going to fail. But if we have a second system.out.println that takes an integer, right, it's going to say, oh, I can't run this one doesn't work, but I know that I'm going to run the one that takes an integer instead. And then we could have some extra code in the integer one that says, okay, I know I need to take this int and turn it into a string so I can use it. Does that make sense?
I'm getting it a little bit, but...
Okay. I guess the main thing to keep in mind, maybe the system.out.println isn't such a great example, but basically overloading allows you to be able to process different types and different numbers of data with the same function call. So I can call display menu, and I could have all sorts of types of data that gets passed to it and have a response for each. Right? I don't have to be like, oh, well, if it's this data, then run this function, or if it's this data, then run this function, or if it's this data, run this function. It can kind of do all that for me. And we'll learn about if statements later, but this kind of, in some languages, you can't overload. If I wanted to say, like, if there's nothing, then I need to display this, I'd have to go, if double jelly beans is null, and then I'd have to run this. It gets more complicated. You have to have a different function name for each one. So this is kind of a simpler way to do it. I wouldn't worry too much about it right now. But kind of, if you just get that idea that you can write different functions that have the same name that take different types of data and different numbers of data. Because again, like, what if I don't have beans that day? I could have a second function that only displays those two. So that way if I only pass in two data, then it knows how to display that, it doesn't die. So, the other thing we want to do is we want to talk about something called returns. So, you can pass data into a function. We know how to do that, right? But also we want to sometimes get data out of a function, right? Like, let's say I have let's get rid of this display menu for now, because we don't really need that. Get rid of those. Whoops, we did that. Okay, so I have the costs of beans, right? And let's say I want to figure out what the cost of beans is plus tax. So I could do this all up here. I could be like system.out.println cost of beans. Maybe we'll do like a dollar sign in front of that. Dollar plus. Right, and then I could be like cost of beans equals, or plus equals, and we'll say it's a 2% or a 10% sales tax. Whoops. Cost of beans times 0.1. And we could do that, and that would work, right? But actually, you know what else? I want to have the cost of gummy bears plus tax, and I want to have the cost of beans plus tax. We could write all that code the same amount of times, but that would be a lot of work. There's an easier way to do this. Let's just write a function for it called public static void calc tax. And we want to pass in a double, right? Because we're going to need to get the number from there. So we'll say double product. And, whoops. Oh my gosh. It's because I keep on accidentally like touching the touchpad with my like thumb and then it changes. Anyways. Add the braces. And inside here, we can now do some operations. Let's say we want to do product plus equals product times 0.1. That will calculate the cost plus sales tax of whatever product is. So now we can go up here and we can go calc tax cost of beans. And we can run that. We can compile, we can run, but it's still going to say $2. Now the reason why is, like as I was talking before, all we're doing is making an operation on product, right? But we're not actually changing cost of beans, right? We're just saying, okay, take the value from cost of beans, do some stuff to it, it does the stuff, and it's like, okay, I'm done. So how we get the value out, right? Because we couldn't go like cost of beans equals product either, right? Because it's not in the same scope, that wouldn't work. So what we do is we say return product. And that was a semicolon. And so then what that's going to do is when you call this function, it's going to return a value. It's going to return product, whatever product is. Now the other thing we need to change is now we finally get to know what void means. So this keyword right here talks about the return type. Void means it returns nothing, right? Which is what we've been working with so far, right? We're just doing calculations. We're not trying to return anything. When you want it to return something, you have to write what you want it to return. For example, a double. In this case, we want it to return a double because we're calculating a double. So we say public static double calc tax. Now, we've got this function is all looking good. We go up here, right? We can compile and run this, and it's still not going to work. It's still going to be 2.0. And that's because when we run this, it gets a value, but it doesn't store it anywhere. So what we have to do is we have to go cost of beans equals calc tax cost of beans. Now when we compile and we run, it's going to give us $2.2. Because what a return basically does is it sets that function equal to whatever this return value is. So when your program is going to the cost of beans line right here, it goes, okay, cost of beans equals something. Okay, let's go and evaluate what that is. So it goes cost of beans equals calc tax. So it goes, okay, let's pass cost of beans into here. Let's do this calculations. What does calc tax equal? Calc tax equals its return, which is, in this case, 0.2. Then it says, okay, cost of beans equals, 2.2. Cost of beans equals calc tax, which equals 2.2. And we could do this with tons of other things. We could do this with cost of gummies equals calc tax cost of gummies. And then if we display this too, we say Control C, Control V, cost of gummies. It's going to, once again, display the right text for that too. So that is returns. Do we have any questions on returns? Gemper?
Wait, so I think we need help.
Okay, so I'll pause the recording for a second.
It didn't do a tax.
Okay, so the mistake that was made is that they had their calc tax function inside of main, and that doesn't work. You have to have functions. Functions have to exist within the class, but outside of each other. You can't have a function inside of a function. You can only call a function inside of a function. So that was where the error was there. Now, speaking of return values, we're going to talk about something called the math class. So, here, I'll pause again. Okay, so the math class is another class that is built into the Java libraries. Now, again, just like system.out, this is such a common class that it's built right in. You don't have to do any extra work. You just say, when you want to use the math thing, you have to first of all say math, because you want to know what class you're looking in. You do a dot, and then you do whatever function you want to do in math. So I'm going to run and grab my book real quick. Okay, now I've got my book, and if I look in here, okay, so yeah, there's a bunch of different functions. There's like math.abs as an absolute value, and you can pass in, if you pass in like -308, it will return 308. Like if we do like a system.out.println math.abs, which is another thing you can do. You can like put function calls inside of other functions, and if we do that, we display and we run, that's going to display 308 at the bottom there. And there's other things. There's like, there's a thing to round doubles down. There's a thing to raise something to a power. There's another thing to do like sines, to degrees, to radians. Some helpful stuff in there. If you need to know what to do, just go and you can look at a documentation. So if I look Java math class, math class documentation. Let this load. You get to something, docs.oracle. This is called documentation. This is going to tell you all the different methods, abs. And see, look, it's even got the overloaded methods. Because abs is actually like 4 different methods. Because it's got one if you pass it a double, another if you pass it a float, another if you pass it an int, and another if you pass it what's known as a long, which is another data type that we'll get into later. And there's tons of different things right there. Cosine, exponent, yada yada yada. So that's something that can be super useful if you find yourself having to do some sort of more complex math operation. For a lot of them, you could probably write your own ways. Like for the exponent one, you might be able to like write your own math function, right, using a for loop. But again, it's easier to probably use math dot pow is what it's called if you want to raise something to the power. So yeah, that's the math class. And another thing, well, should we do some work with math? No, I mean, I think the math class is, does that make sense to all of you guys, how it kind of works?
Wait, how do you do the exponents?
How do you do the exponents?
Do the power, so it's,
yeah, so you do math.pow, meaning like power.
and then can you control, or how do you control what it's to the power of?
Yeah, so you go and then you put in 2 numbers. You can do like 5, 2.
And then it would be 5 to the power of 2.
Yep. And there's, the documentation explains all of that. It's useless to try and memorize all of those functions, right? If you use it enough, you'll memorize it. Like, this one I've kind of remembered because I've used it a few times. But again, there's no way you'll ever memorize all of the commands for all of the classes. So it's good to know where to look, right? You should remember that if you want to do math stuff, probably a good idea to look at the math class first. But also if you get stuck, you could look online and be like, how to do powers in Java. And someone online would be like, look at the math class, or look at this class. Sometimes there's even other classes that aren't the math class that have math in them. Right? There's people who have written their own classes for math. Math should be all you need to really use for now, but a helpful thing to do. And an example of return values. Because if I wanted to be like, I have an int called not called -4, but int value equals -4. Also, value is a terrible name to have as your variable name. I probably wouldn't do that. But I want to get the absolute value of value. So I say math.abs value. And that would compute, and that would give me 4 in the place of value. So, yeah, I think that makes sense. Now, the next thing we're going to move on to is working with the string class. Because I told you guys, the string is also a class, just like our Hello World class, just like our the math class. String is also a class. Now, I'm going to just, get rid of a lot of this stuff. Add a bracket because I deleted one from main. And in fact, I'll tab this guy in too. Okay, so we're kind of back to square one. A blank slate. Now, there's a couple of functions that are in strings, and you use strings a lot, so it's a good idea to know about them. So, first let's declare a string. String, you'll notice, is a bit different because you declare it with a capital, right? And that's because it's not a raw data type. It's not an integer. It's not a double or a float or any of those things.
Or a public.
What, sorry?
Is public like a... Because public, static, and void are all like lowercase.
Public, static, void. Oh, these things?
Yeah.
Up here? Well, those are lowercase, just because string is capitalized. Let me find where this is talking about it. Yeah. So string is capitalized because it's a class, right? In classes, you capitalize the first word. Or the first letter, sorry. So we do string, and let's name our string S1, okay? Now, one of the special things about a string is you can actually write out literally what it is, right? This is a string literal. For most classes, you don't have literal versions of it. Like, that's something that the people who wrote Java were like, okay, yeah, strings are used so much, we should probably have a simpler way to declare them. But for your own classes, you won't have that kind of stuff. Now, let's say I'm going to have this be hello world, something we started out with. Now, when we're looking with strings, a lot of times what we want to do when we're doing operations on strings is we want to look at the individual characters, right? Like, let's say I get someone's, like, I don't know, like, they type in, like, I want my money to be 3, or something like that. Okay, and like I don't really care about I want my money to be. I won't care about the value 3, right? So what you do is you want to look at each character and find the ones that you really care about, the ones you don't care about, and kind of do some work with those. That was a really bad example, but yeah. So if we have like string s1 hello world, to work with characters, you have to remember a few things. / hello world. I'm gonna add a underscore right here to represent a space. You wouldn't actually have a space right there, but just to represent so it's clear. This is how these are numbered. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10.
8.
Oh, okay. 8, 9, and 10. So again, this is what I was talking about before. It starts counting at 0. So if I wanted to, and this would require some more advanced stuff, but like let's say I wanted to go look through a series of letters until I found Z. Right? I wanted to know where Z was, right? I could do, for int I equals 0, and I could say, okay, first look at this place. character in place 0, then in place 1, place 2, place 3, and keep on going until eventually I found that. That requires an if statement, which we haven't learned about yet, but we will soon. So, that's how it's numbered. Now, how do you access these characters? Let's say I wanted to get the first character, right? I could say, okay, and for this, we have to actually, remember how I talked about chars, right? And how you define those. Let's say char x. We'll just call it x, because I don't know what to call it. You never want to name variables x, unless like the x coordinate, because like that's a really non-descriptive name. You'd lose points for that, but just for the sake of time, we'll just call it x. So we'll say x is a character, right? And we want x to be whatever the first character is, because we want to know what that character is. So we say x equals s1 dot char at, and then we put in 0 to denote that we want the first place. Now, this is a kind of interesting thing, because we've never really seen that before, right? When we have an int, we can't be like, this dot do something, right? Because that's not a class. Again, when we create string s1 equals hello world, it's kind of interesting. We are actually not only referencing a class, like with the math class, right? We said math dot do this function, and it did that function to return something. With this, we are actually creating an object, right? We are creating an object called s1 of type string, and it has each string object has a value, hello world. It has different functions that you can use. So we're saying, okay, go to the s1 class, right, and do .char at. So then inside of the string class for s1, it says, what's my first character? Return that. So then, if we do system.out.println x, compile, and run, we're going to get h, which is all we wanted. We wanted that first character. Another thing that's pretty useful is s1.length. That will return us how long the string is, which is good because we want to know how long it is when we're looping through. And actually, I think that's what we're going to do next. We're going to kind of jump a little bit ahead because I really want to talk to you guys about if statements. So an if statement, and I'll go over this in more detail later, but an if statement goes something like this. It says if x is smaller than 4 or x is equal to 4. It's, remember like the tests from for loops? An if is a test. So let's say like just this random, you don't declare, that's the thing, you don't declare an int inside of it, but you have an int outside of it. So let's say I have int x or int y equals 0. I'll say if y 2 equals, because we're not setting y equal to 0, we're saying is it equal to 0, then curly braces, run this code. So if y is equal to 0 and that test checks, it runs through that code. Otherwise, it skips over it completely. So, something we can do that's kind of interesting with for loops is, let's say I've got some special character in here. Like let's say, in my string up here, I am hello world, and this guy, there's a random hashtag in there, and it's bugging me. It's like it's done something wrong. Okay, I need to find out where that character is. So what I could do, set up a for loop. For int I equals 0, because remember we're working with strings and start counting at 0. Now, what would our test be? Right? We don't want to have the loop go on longer than the string is in length, right? So what we do is we could use s1.length. Right? And then that'll, no matter how long the string is, it'll only go on as long as the string is. Then we do I++, fairly straightforward. Do that. Now, here is the kind of interesting part. Let's say if, using that new statement, if s1 dot char at I equals hashtag system.out.println. I found it. So what this is going to do is, again, this is something else you can do, right? This evaluates to a character, right? Oh, whoops, sorry, that's the other thing. A mistake that I almost made right there. This is going to give us a character. The quotation marks are for strings. A character literal is defined by a single quotation mark, like that. Okay. So if we compile that, and we run that, it prints out H, like up here, like we had before. Who cares about that? But it's going to eventually say I found it, because it's iterating through it. It goes, okay, I is equal to 0. Let's check. Is the character at place 0 equal to this thing? If not, we skip it. Okay, repeat this. Now I is 1. So now we're checking the second place. And then the third place, fourth place, fifth place, sixth place. As long as it's as much as there is length, until we eventually find that, and then we say I found it. Yes, Kemper.
What does hello world have to do with like I found it?
I found it? Oh, so basically, like, I hid this character in here. It hid the character. And so it was like, whenever it finds that character, it says, I found it. So like it found the character in there. So that's something kind of interesting that we can do with those. Let's say I have a website, okay? And someone comes in and they type in two things. They're like, where do... So I ask them, I'm like, where do you live? What town, what state, what country? Okay? And let's just do town and state for now. So they say, I live in Redmond, Washington. That makes sense, right? That's pretty simple. We go down here, and that's like, I don't want to have a string that says Redmond, Washington. I want to have a string that says state, that says Washington. I want to have a string that says the town that they're in. I want two separate strings. Now, using this same little thing we have down here, we can actually figure this out. So, again, we could number those, but for the sake of time, I'm not going to. That might help, though. But if we go down here, let's see. So, I'm going to define a int called let's say, we'll just call it x1 int y1 int x2 x2 int y2. Now, why I'm using those is going to become apparent in a second, okay? So I'm going to iterate through this thing, right? I'm going to say, okay, so I'm going to go through as many strings as there are, but what am I looking for? I'm looking for, let's say, the comma character, right? So once I found that comma character, I want to, well, okay, let's see. So after I'm done with this, what I really want to do is I want to separate those things into two strings. How you can do this is using s1.sub, is it a capital? No, just one. Substring. And this takes two parameters, a start and a stop, right? So the start so does that make sense? Like, it wants to know what character am I starting at and what am I ending at. It takes that, pulls it out of the string, and returns it, right? So for the town, that's pretty simple. That's just going to be 0. It's going to be the first place. But for the second place, right, where the string ends, who knows? That could be in Kirkland, Redmond, whatever it is. What I need to know is that's why I created these variables up here. I'm going to call this y1. Oops, y1. And we will store this in a string called town equals that. And then we'll do a string called state equals s1.substring. And actually, you know what? We only need really one variable. We'll just call this x. So for now, we'll just leave that blank. Okay. So if we go over here, right, we're iterating through. And that's what it's called. Iterating is when you go one by one over and over until we find this comma, right? So once we found that comma, what should we do? Why don't we save what number we found the comma at? Right, that would make sense. So let's say we found it at whatever it is. Let's say x equals I. So only when it finds that character, it sets x equal to wherever that character is. So now we have a stored value of where the comma is. So now we could go over here and we could say, let me check this. So the one thing about substring is when you put in a value, right? Like if I put in 0, it's going to say, okay, start at 0, including 0. But if I put in like 3, it's not including the 3. Does that make sense? So if I'm like, okay, get me from 0, 3, it would take these. So it doesn't include the last one. If I wanted the whole string, I'd actually have to say 0, 11 to get the whole string if it's 10 characters long. That's something to keep in mind. So this will work. I just put in x, right? That's going to get everything up into x, but not including x, which is going to give me the town. So that looks good. Now for down here, well, first of all, there's a space there, so I probably want to skip the space, right? So I will say, x plus 2, right? Because we're skipping over this space. So we're starting at where the comma is. We're saying, okay, plus 1, now we're at the space, plus another 1, and now we're at the beginning of the state. And then for the end, we go, s1.length plus 1. No, I don't think we need the plus 1 because it'll give us. Does that make sense?
No.
Okay, because s1.length, it's not going to tell us, oh, your string is 11 characters long if it's 12. Right? So the string only goes out to place 11, but it's got 12 characters in it. Is that okay? So when we this is going to work, and the reason it's going to work is because, right? You understand where we start, right? Mm-hmm. We start with the x plus 2. That gets us to the right starting place. Now to get to the end place, right? To get up until the end of the string, we need the last place of the string plus 1. If it's let's say a 12 character long string, the last place is going to be actually 11 because it starts counting at 0, but the length will be 12. So if we just put in the length here, it will get us 12, which is what we need because it's up to but not including the last one. Is that?
I think so.
Okay. So now if we go back up here, hit enter, and let's say system.out.println, and we'll say town of, we'll say town, and system.out.println state of plus state. Now if we compile this and we run this, assuming, oh, where did I make this mistake? Cannot find symbol. Oh, okay, that was from an older when we were working with it before, and that's something I forgot to do, to remove. So now it should be good. Let's compile. Let's run. What? We had the comma, right? Yeah. Okay, I think what it is, I think we need to initialize this and say that it's a value. Yeah, okay. So the reason it was giving us an error right there is because this code right here, the for loop and the if statement, it's not guaranteed to run, right? It's totally possible that that if statement could not run. If there was no comma in the string, the if statement wouldn't happen. So it's saying, hey, then I don't know what x is, because we just said x is a box. We didn't put anything in it. Mm-hmm. So that's why it was making me actually define it and say x equals this. So, but then that works. We get town of Redmond, state of Washington. That was kind of complex. How are you guys in the if statements? Or do those make sense?
I forget what that means.
If it's like you do the test, right? If the test is true, you run the code inside of it. Otherwise, you skip it.
Oh, so it's looking for the comma, and if it finds the comma, then it makes a substring that says town of and state of.
So okay, so what it does is it goes. Okay, first int I equals 0, right? So if the character in the 0th place, the first place, is this, then store what place we're in. Does that make sense?
Wait, so you're saying if the first...
We're basically, by changing I, we're going through each one of these things and checking if it's a comma or not. We're saying, okay, at place 0, is it a comma?
No.
Nope. So we don't run that if statement, we just skip it. At place 1, is it a comma? Nope. Place 2, place 3, place 4. It just goes on until eventually it's like, oh wait, that is a comma. In which case, we want to store the value of I, because I is the place we're looking at, right? Does that make sense? If we find it when I equals 3, we want to store that so we know where that thing is. So, we have successfully broken that up. And now we have those two strings that say town of and state. So yeah, that's kind of I'd say that's a fairly advanced application, because it took in a lot of things that we learned with the for loops, plus adding in the new thing. But so how are you guys feeling on that overall? Still good?
Yeah. I mean, I understand it mostly, but sometimes, like,
It kind of seems...
I'm not going to remember how to, like, write the whole thing down.
Oh, yeah. And I mean, is it really the if statement, or just kind of the whole thing in general?
It's just the if statement.
The if statement?
With the two substrings, yeah.
Okay, if statement and the two substrings. So, we'll probably be working more with substrings later on. It's possible. I mean, for now, substring, if you forget what substring means, right, you can look that up online. Be like, what does substring mean in Java? And that you can find that, and there's tons of stuff that'll say that. The if statement we will do more work with later. And in fact, there's a second part to the if statement called else, which is fairly interesting, and we will go more into that next time, but I think we are actually...
Over?
We are over. It is 2:59 p.m. So are there any last minute questions?
Wait, for the else, is it just like, if it is in that scenario, then it does something else?
Do you want me to run? I can...
I mean,
No.
Here. So there's a few things. There's else if, right? So if the first if statement is false... Oh, this isn't... Yeah.
False, then
So if the
else.
first if statement is false, it goes, okay, if not that, then else if, and it checks that. If that's still not correct, you can make another one that says else, which runs if all of the other things are false. So yeah.
Okay, so else if is pretty much it runs that after if doesn't work.
Yeah.
And then else
Because
runs everything
if you have if this equals this, and then if this equals this, right, it will run and do both of those checks. But if you only want it to do that second check, if the first check fails, then you would use an else if.
But if you want it to do one after all of them fail, you would just do else.
Yeah, if you want something to happen only if all of the if checks fail, you do else.
Right.
If you want it to happen no matter what, then you don't need an else. You just put that outside. And we'll go much more in depth on that later, and really working on that. A lot of programming is if statements. The one thing is, though, you want to be careful with them, because they make a lot of sense, and it's really easy to write a whole bunch of if statements when there's really a lot shorter ways and a lot better ways stylistically to write your code.
How many classes will there be?
How many classes will there be? Well, we have made it through chapter 3. So...
Running out of time, heard it.
Yeah, I know. Hey, Max.
What's up?
So yeah, I think we are done for today's lesson. Finish the recording.